Number 17, I'm up in the 3 space. I've got 2 points that are called P1 and P2, and I'm meant to calculate the vector P1 to P2. So take the first component of P1 to P2 is the first component of P2 minus the first component of P1. Remember, they do that thing where you reverse the order of the points. P1 to P2 means that you put the component of P2 first. So 2, 9, and negative 2, if you like, and the first term in each 3 of these slots. And then 5, 7, negative 1. 5, 7, negative 1 is what gets subtracted. Okay. So I wanted to draw a picture. Oh, by the way, I went from component form here to this form in which I've used the standard basis vectors, or the standard vectors for 3 dimensions I, j, and k. I should point out, since it's the first time I've done this in a video, that I put hats on I, j, and k much like I put harpoons over all of my vectors, I put hats over all of my unit vectors. This way you know who's playing the role of a vector and who's playing the role of another kind of object like a variable or an arbitrary constant or something like that. Okay, so I got started down here. I drew a 3-dimensional space, and I went out to draw P. I went out 5 over 7, and then down 1. And similarly for P2, I went out 2 over 9, and then down 2. That's a decent job. And then from P1 to P2, so that's from this guy over 2 to 9, negative 2. About like that. And so let me look at the various parts of this guy. Negative 3 times I, or negative 3 in the first component, that means I'm moving backwards 3. Good, yeah, yes, I see that right here. I'm moving backwards from 5 to 2. Okay, so back into the picture. Next component is 2. That means that I'm moving 2 to the right. I can see that right here. I'm moving from there to there. I'm moving 2 to the right. They go from that point to that point. Okay, and negative 1 here, or negative 1 times k in this standard vector notation. That means I am moving negative 1. I'm moving downward. Now, from this perspective, it doesn't look like I'm moving downward very well. It doesn't very much look like I'm moving downward, right? Because we're taking this view that we're looking in from this angle. If the axis, right, or if we could rotate this whole system and bring that axis up so it's kind of pointing straight out at us instead, then we'd be able to see that this was going down a little bit more. But it's an artifact of the perspective. It looks like it's going up. Actually, it's going down. Well, it all makes sense to me. I hope it all makes sense to you.